All right, so here we're supposed to solve numerically or graphically and then write our answer in interval notation. I first am going to say, well, let's solve it just normal way and symbolically, and then we can go the other ways. So we're going to have to add 2 to all three parts since it's tripartite. So we'll have 3 less than or equal to 3x less than or equal to 15. Divide by 3, divide by 3, divide by 3. So 1 less than or equal to x less than or equal to 5. So we're going from 1 to 5, basically. Okay. Now, next thing is we have to do, let's do it numerically. So what we're going to do in any case, we're going to say let's let y1 equal 3x minus 2, y2 equals 1, y3 equals 13. Okay. And so what we want to do then is we want to make x, and then we'll do a 3x minus 2. And this is going to be used for either numerically or graphically. And so this is kind of how we're going to do it. So let's go 0, 1, 2, 3, 4, 5, 6. Now if we plug this in, we get what? Minus 2, and then we get a 1, 4, 7, 10, 13, and then 16. And where is it 1 and 13? Well, that is here and here. And so it's going to be between those because we know it's going to be between this and this. And so we know we're going to have between what? 1 comma 5. Okay, so that gives us this. So that's the numerical. Now, graphically, what do we have? Well, this one is probably going to be harder to draw on here because it's hard for me to draw on here. Hard to me draw anywhere except for on a computer with graphing. So let's go 2, 4, 6, 8, 10, 12. See, we've already not got a good numbers here. Let's erase that. Um, we can probably have more on top, I think. So let's go this way. So we'll go 2, 4, 6, 8, 10, 12, 14. And we'll stop there. And we'll go 2, 4, 6, 8, and 2, 4, 6, 8, and negative 2, negative 4. All right. So we're going to have y2 equals 1. So we'll have a line at 1, and we'll have a line at 13. So that's 2, 4, 6, 8, 10, 12, 13. And then we graph this one, 3x minus 2. So minus 2, we have a point. And then we're going to go, oops, that's minus 4 there. Better not do that one. I guess we erased everything. So that's minus 2. Then we go up there and over 1. So that would be here. Then we go up 1, 2, 3 over 1. So that'd be there. Then we go over 1 and up 3. So that'd be about there. Over 1 and up 3. So that would be about there. Over 1 and up 3. That would be about there. And we want to be between those. So that's here. That's at 1. And that one is at 2, 4, 5. So between 1 and 5, again, is where we want to get it. So we get 1 and 5 here, 1 and 5 here, and 1 and 5 here. So no matter if we do it symbolically, numerically, or graphically, we get the same answer on that one. Okay, let's do it again, except now we're going to use this. And so with this one, symbolically, easy, we just subtract 9, subtract 9. So 2x is less than 2, divide by 2, divide by 2, x is less than 1. All right, so subtract 9, subtract 9. 2x is greater than or equal to 4. X is greater than or equal to 2 after we divide by 2. I guess I left that step out. All right, so if we graph this, that's probably going to be the easiest thing numerically here. So it's going to be, here's our 1, here's our 2. So it's going to be greater than or equal to 2 or less than 1 because we have the or. And so it's going to go from negative infinity to 1, parenthesis, union, 2 to positive infinity. Okay, so that's kind of our symbolically. So this is kind of A. B, it says graphically. All right, so let's see if we can draw this one graphically. So again, we're going to say y1 is equal to what? 2x plus 9 because it's the same in both of them. Y2 is equal to 11. Y3 equals 13. Okay, so now let's try to graph this one. And I think everything's way up there, so we'll start at 0. And so we'll have 2, 4, 6, 8, 10, 12, 14, and 2, 4, 6, 8. And so 11, so 2, 4, 6, 8, 10, 11. So that's about there. And then 12, 13, close to that. Not quite, but it looks good. And then 9, 0, 9 is going to be a point. So 2, 4, 6, 8, 9. Then we're going to go up 2, so 10, 11 over 1. So that's going to be about right there. Give me a dot. Then we're going to go up 2 again. 1, 2 over 1. So that'd be about right there. So this one, when we have the 11, it's going to be an open circle actually. So it's going to be an open circle here, and it's going to be a closed circle here. And so it's going to go down that way, up that way. Again, rough estimate, because we want it to be this to be less than 11. So it's going to be less than 11 from here down. So it's going to go from negative infinity up to, and that's at 1 union. And here we're going to go from 2, it's a bracket because it's going to be equal to here because of this, and going up to positive infinity. So that's how we would do it graphically. Now numerically, again, we're going to have x, and then we'll have a 2x plus 9. And I don't know, let's do 0, 1, 2, 3, 4. And 0 gives us 9. Then we'll have 11, 13, 15, 17. And so here we have 11, here we have 13. And so it's going to be everything less than that. So it's going to go from 0, negative infinity rather, up to 1, parenthesis, union. Now it has to be equal to this one. So bracket 2 to positive infinity. So that's kind of how it works here. So we're going from this point where it's an open circle to this point where it's a closed circle. Again, due to the closed circle and open circle. So that was kind of symbolically, this is kind of graphically, and this is numerically. Okay. Now, personally, I think the easiest way is this way because it gets us there quicker. This way, it's you get there, but if you draw a graph bad, then you could be off a little bit. This way is easy too, except sometimes you have to do a lot of points to be able to figure out where your two pieces are here. The 11 or 13. Maybe it was further out, and you had to do maybe 10 points because you chose the wrong points to do here. So that one could be a problem depending on what you choose for your points here. So that's how that one works. All right, so let's pause there and come back for some more.